My name is Pedro. I work in infrastructure operations at Facebook, and I'm going to talk a little bit about how we scaled the operations organization over the last 4 years. So the way that I view the world is sort of like basically in 4 phases. I think of it in the times when things were on fire, when we focused on a smaller set of things, but we actually did them better, when we grew the teams and took on more responsibility, and then how we approached automation over the years. So when I started, the world was pretty much on fire everywhere. Our user base was growing, our infrastructure was doubling year over year, and we were expecting to do that. The user base and infrastructure were doubling year over year, and we were expecting to do that every couple of years in the future. So we had a team called SRE, and it existed to keep the site up and running. They were a 24/7 team that worked tirelessly over that time in 4x10-hour shifts over 2 regions to make sure that Facebook was up and running. And while it was rare that the whole site was down, there were definitely pieces of infrastructure that were down at any given time, and SRE were the primary responders to those problems. We also, so when I think about the name SRE, I think Google SRE. That's probably what everybody thinks of, right? They were the ones that sort of set the standard. They started with the name. Everybody picked it up. And basically SRE would be like a team of systems and software ninjas who just like know everything about a particular infrastructure, what makes it tick, how to fix it, how to make it better, how to scale it, et cetera, right? And they're also the guys who know how to bring it back up if it really fails. The problem that we had at Facebook was that the team was small and it was like incredibly interrupt driven. They were generally involved in launches after they happened, not during the formative stages with the engineering team. And generally they were only involved when a problem came up after the fact and when it was up in production. Alerts or alarms were raised on individual systems. They had to be fixed manually if anything came up. People were usually SSHing into a box. And when there were fleet-wide problems, we really only had like one tool to use, which was a distributed shell program that we could run commands across the fleet to fix the problems. It was an awesome tool, and it saved our hide a lot, but it was really kind of the only tool that we had. And any project that SRE was responsible for spanned months, not weeks or days, and I was talking about months and quarters probably. And basically SRE just couldn't engage in projects because they didn't have the time. We also had another team named AppOps, and that team was actually much more like the SRE team that you would think of. They were experienced software and systems engineers embedded with the engineering teams, making sure that they could understand what was actually happening in production, building better services, making sure that they were architected in a way that was reliable and stable. They understood the service end to end, and they knew when things went sideways. They sat together with the engineering team so that it was actually sort of part of the team, an operations person part of the team, rather than having operations off to the side like a traditional ops organization. And their challenge was a little bit different than SREs. They hadn't been able to hire anybody in about 9 months. We had 5 people covering 13 big services on the site, and the way that we define big services is by something that has hundreds or thousands of servers in it. And they were basically on call all the time, 24/7. I remember being in a meeting with the 5 few people that we had, and we were asking to talk about some sort of difficult items, and we asked them to close their laptops unless they were working on an emergency, and nobody closed their laptops, right? So they were clearly stretched thin, right? Hiring was also a really big challenge. Both AppOps and SRE were really looking sort of for unicorns out there. They needed people who were highly experienced in software, systems design, systems administration, TCP/IP networking. They had to know each of those things inside and out, and if they were weak in one dimension, they weren't going to be hired. SRE had similar requirements, but they were actually able to, they were hiring for less experienced people. And in SRE, when we did find people, we had to convince them to actually come in, work shifts, and firefight about 85% of the time. So it was awesome stuff. Across both teams, we really had no consistent way of evaluating the skills when we were interviewing and deciding whether the person that we were interviewing was going to be hired or not. Overall, for a period of about 12 months, we hired 4 people into AppOps and 6 people into SRE. So we definitely had to do something different. But despite those problems, the users kept coming. Users didn't care that operations wasn't scaling, that we couldn't hire people. We were doubling our user base over and over again. And the days of Facebook being able to sort of selectively open up to colleges were over. It was open to the world. Everybody was coming, and they were coming in droves. Over the 4-year period, like I said, we doubled our active monthly user base in both 2009 and 2010. In 11 and 12, we started to taper off a bit, but not by much. You can see on the graph that even today, we're still on a steady incline of users being added to the site. And we also kept hiring software engineers. we didn't really have a problem getting new people for software engineering. And to illustrate this point, this is sort of a graph of the commits per month over time to our code repositories. And we kept a steady pace of new things being added and developed. And in fact, from an engineering perspective, we kept adding new services at about the rate of 2.4 times every year. So to put that into perspective, if we ended the year 2009 with 13 big services, we had about 30, 31 the next year, and then we had about 70 or 74 the year after that. In the last few years, we actually did taper off a little bit, and we're not growing as much in big services, because we did have an infrastructure engineering focus on building common infrastructure, and people build services on top of that. And because the users kept coming, we needed to add more and more capacity to an already pretty large infrastructure. I remember back in late 2009, it used to take us about 6 to 8 weeks to turn up a cluster of about 10,000 servers. And by anyone's standard, that was pretty good, but really not by ours. I remember talking to the capacity and engineering team at the time, and they said that in 2010 and 2011, we were probably going to double our infrastructure and add twice the amount of clusters. I did the quick math, and I knew we were in trouble. There was no way we were going to be able to do that. From an ops perspective, we just weren't keeping up with the company, and we were actually going to be the hindering factor for the growth of the company. So we had to do something radical. So now that we knew that we weren't actually going to scale with the company's growth, we needed to figure out what we were going to focus on. This is one of the hardest things that we had to do, and in general, that anybody that has to do prioritization calls knows this. When you have 50 things that are on fire, which one do you choose? Which one do you drop? What project do you invest your time in? So we took sort of a people and data-driven approach to the problem, and in the beginning, the first thing that we did was when we looked at what we were trying to cover from an operations perspective, we just realized, and what was expected of us, we just realized that we couldn't actually scale the organization because it wasn't structured correctly. So the first thing we did was we refocused the teams. We swapped the E for an O in SRE and created a group called SRO and hired people with a different set of skills or different focus on the site. They didn't have the responsibility of working directly with engineering on any new services that were being built. And the change was also sort of to signal that the SRO team was a team focused mostly on incident management, fleet-wide problems and operations, the overall health of the site. They also just needed to only worry about fleet-wide issues and then get out of the individual server break fix mode. That was the biggest thing that they had to work on. But it was also just a way to reset expectations for the company and the operations org, right? The old SRE was also supposed to own pieces of infrastructure like our imaging repositories, bringing up new services, et cetera, and adding new capacity. But again, since they were stretched so thin, we decided that we were going to build another organization called ClusterOps, who was focused on basically turning up new capacity, load testing it to make sure we could actually use all our servers in the right way. And we hired separately for that team with a different set of requirements. And just in general, we actually did focus a lot of our time on changing the recruiting and hiring practices, and I'll get to those a little bit later. So now with SRO in place, we needed to sort of better understand where people were spending their time. We needed to know what the most broken thing was. So we started pretty simple. We instrumented the work that the humans were actually doing. We just logged every SSH session to every server. Every time that a human acknowledged an alert in our alerting system and had to go work on a box, we logged that as well. So pretty quickly we came up, and in our logging infrastructure, we came up with a way to understand which one of our systems was the most broken, because that's the ones that we were fixing the most often. We looked at that data basically sort of on a two-week rolling basis to make sure that we were still focused on the right thing, and then working with the engineering teams to automate their problems or come up with better solutions for what we needed to do in each type of service. This is a representation sort of the way that we looked at this data. This is recent, so it's no longer really that relevant. It's not easy to see the spikes, but in the past we used to see big spikes on things like cache or ad systems or something like that, right? But with that data, we knew we could take an easier way of prioritizing our work. So remember I had said that we really only had about 5 people and 13 services in AppOps. We just needed more people. So since we had changed the focus of SRO and we were hiring different there, and we were able to actually get more people into that team, once we had a new batch of people in there, we actually took some of the old SRE folks and put them in AppOps, and we basically doubled the amount of people in that team overnight. But after about 4 to 6 months, we had to take another look at that and said that even now with twice the people, it still wasn't enough. So in late 2010, we actually reduced the number of services that had quote-unquote ops support on the site by half, and then we sort of bin packed everybody into smaller sets of teams. It was a difficult decision. We had to decide like what's core to the site's stability and availability so that we could actually run a site in a steady manner and come up with a smaller list. And we had to speak with engineering managers, engineers, even the operations engineers, and sort of talk to them about the reasons why we were doing this. The conversations were like basically, hey, we're going to take this 1 or 2 operations guy that's adding a lot of value to your team, and they're going to go away. And we're going to give you minimal support because we don't have the people. Lots of people weren't happy about it. I did have a lot of conversations with managers that disagreed. Ultimately, looking back now, I think it was the right call to make. So now we actually had teams of 3 or 4 people, right? Still very small by Facebook scale, but with these resources, we were able to start investing in tooling. We could now have a rotation of people who worked on the operational components of a service or the tooling or the instrumentation aspect of it. And things were still on fire in some places, and the big services that we had, the way to approach that, the prioritization call wasn't as easy as we did with SRO, because there was one guy who was SSHing to all the boxes in a service. It really didn't help us. We had to do much more of a brainstorming session to understand what the pain points were, take a lot of anecdotal evidence, write it down, and then come up with a prioritized list. Once we were able to do that, we actually could come up with a couple of sets of tools that really helped us understand what was going on in the infrastructure. So one of these tools that was built by AppOps is called ClassPin, and it's basically just a high-density heat map to really find trouble spots. Before this tool, the operations team on cache would know that there was a problem because they had a flood of alerts, either on their interface or through email, and they had to try and actually digest all that information all at once, and it was really complicated and difficult to do. If anybody knows, when you're flooded like with thousands of Nagios alerts, you're like, yeah, the whole world's on fire. I don't know what to do, right? So in this tool, if those kinds of things happen, we could go straight to it and find out, say, if a rack of servers was down, if there was a cluster that was overloaded and didn't have enough CPU, we could actually narrow down the places where we had to look at problems. So our hiring continued to get better, and we added almost about 3 times the amount of people in 2011 than we had in the years prior. And those people actually started going through our normal software bootcamp that we have at Facebook, and you can probably look up a lot about that. I won't go into it. But this taught them a lot about the standard Facebook coding practices, how to navigate the code base, the general structure of the site and the software that's written to actually operate the site. But it also gave them clout, and it built up relationships. Before, engineering didn't know what operations didn't really have sort of an insight into the kind of skill sets that we were hiring. So now, putting them into software bootcamp, we sort of forced the mentors who were working with them to actually understand their skill set, build relationships. At the end of it, they also had to, quote unquote, graduate them and basically sign off that they were going to be productive engineers in the company. Once we had enough of those sort of types of engineers, and they outnumbered the traditional sort of systems administration focused operations people, we changed the name again. We felt that the change was right at that time. We rebranded AppOps into production engineering, again, retiring the old moniker so that we could actually start over and reset expectations for the team and the company. By dropping the operations part of it, it was interesting. We actually wanted to signal that we were hiring strong engineers, not traditional sort of operations people of what people thought they had been used to dealing with in the past. Now, since we prioritized on a smaller set of services, we still had to figure out that, we still realized that there were a lot of things across the infrastructure that were broken. So we had to come up with a way to actually figure out the biggest problems on the site that didn't have this operational focus, or people who could sort of raise the really big problems. So we decided to devise a new postmortem program, and we sort of slapped incident management on top of it, because postmortem sometimes doesn't ring true to a lot of people. And it was a joint effort between the software engineering and operations leads to make sure that we were having productive conversations around the biggest incidents. In the beginning, only SRO was creating SEVs. SEVs is what we call sort of like the big incidents on the site. And slowly, other engineering teams started to get on board with it, and they understood the value of it, and it just took a long time to get there, but they did. And then every week at the end, we review the biggest incidents. We still do this today, actually. We review the biggest incidents from the previous week. And it helps us sort of find out whether we have deployment issues, or we have tooling requirements that nobody's paying attention to, or if we have human errors that we have to try and address in a different way. If it was a human mistake, we honestly didn't care who did it. It wasn't about blame. We actually wanted the engineer who caused the problem to come in and tell us why what they did wasn't sufficient, right, in their eyes. We learned a lot and iterated on infrastructure components, and we got better over time because we had open discussions about this. When we first started it, there was definitely some people focused on things about like why something happened, why it was so bad, why if we only had Y or X, we actually wouldn't have had that problem. And those discussions were just really never that productive. So we actually took the slogan, we put it on a t-shirt, and we handed it out to all of infrastructure. And we wanted to signal that we really wanted to go through a cultural shift of having people fix things, not necessarily whine about why we don't have better things yet. And then when we started this, there was still some hesitation from a lot of teams. SRO would call engineers in the middle of the night. They were often confused about who they were calling and why. The engineers wouldn't answer the phone. Being on call at that time just wasn't part of the software engineering team's DNA. It was just new to them. We honestly didn't even have a good on-call scheduling tool at the time. So we had a software engineering team build one, and it was a big deal. But slowly over the course of months, we had a lot of high-level managers who had to hound some engineering teams and get them on-call schedules, and eventually after a while, we actually did have everybody on an on-call schedule. But even with that on-call list, for a while, we still had some trouble raising some folks. We would call them, they wouldn't answer, they had their phones off, they didn't remember that they were on call, this kind of stuff. And so we had an idea of who those people were or which teams were doing something better than another team, but really it was only anecdotal evidence. So we had to come up with, yet again, a data-driven approach for the hundreds of engineers to say, like, this is where the trouble spots are. We can't get a hold of these types of engineers. So we built an auto-escalation tool that could quickly cycle through the team. So basically, you bring up an on-call list, and it gives you the person who's on call. You chirp them. That's what we call paging somebody and having them come on an IRC or something. And if they don't answer, it will actually go to the next person. And if that person doesn't answer, it goes to the next person on the on-call list. And we cycle through that whole list, and if nobody answers, then we call the manager. If the manager doesn't answer, we call the manager's manager, and we just keep on doing that. We stop at Zuck. There's no real point at calling him. This actually worked out really well. It basically did a couple of things. One, we were able to show the engineering managers, hey, here's a team that's just not doing what they're supposed to be doing. Here's an expectation that we have of them and the company has, and they're not actually answering. The second thing is their peers shamed each other. So if you called an engineer who was on call, but they didn't answer, and you called the next person, and that person did answer, and it ruined their movie night, the next morning they came over and they'd say, hey, dude, why didn't you answer your call? I expected you to be on call. You ruined my night. Do your fucking job, right? This changed pretty quickly. So now with all that stuff happening, we did have a parallel effort to change our hiring at Facebook. So I'm going to talk a little bit about some of the things that we did to get to hire a couple more people and expand the scope of operations. So we spent a significant amount of time looking at our interview questions and how we were evaluating people. We knew that we weren't hiring the right way and we had to do something different. In our traditional interview, before we made any changes, we actually had every person do a little bit of every type of interview. You basically had the same type of interview by 5 people, and we weren't really having the amount of signal that we were looking for. If everybody asked somewhat of the same software question or some of the same design question, it really wasn't helping us. So instead what we switched is we had one interview focus only on one set of things. So each interview had to ask specific questions around networking or coding or design or systems administration. And we added a 5th one, which was about culture. We wanted to understand the type of people that we were hiring into the organization. We also had to build completely new questions. The questions that we had just weren't good enough. It wasn't easy for the interview to scale their question based on the years of experience that a candidate had. And I'm sure that before we did that, we lost a lot of good candidates because we'd ask them a really high-level question and that a senior person would know, but this person had less years of experience. They'd get all flustered, they'd get nervous, and then the whole interview bombed, right? It wasn't necessarily that they were a bad candidate, they just didn't know how to answer that question. And then we felt that culture was a really big component to building the right type of team. If you hire a bastard operator from hell, then people are not going to really want to work with you. They're going to turn people away. They're not going to want to come and talk to you either. If that works for you, great. There are definitely companies who actually have those people, and they work, but it doesn't work for me. So they're really just not going to make things better in your organization, from my perspective. So a couple of weeks ago, I saw a keynote by Jez Humble that was talking about building organizations. And he had this diagram that I shamelessly stole off of his slides, which is a great way of sort of looking at how to define a culture in engineering. This diagram was built by a guy named Michael Sahota, based on a book by William Schneider on engineering culture, if you can follow all that, right? But he divided this culture into like this neat way, and you can see like these 4 dimensions highlighted here. There's some words that jump out at you, specifically things around control or competence, or cultivation or collaboration. And it made sense to me that organizations kind of fall into one of these quadrants or somewhere around on this diagram. Ops teams, or traditional ops teams back then, definitely fell a lot more towards the control quadrant, and we probably all know about that. And so when I got to Facebook in 2009, ops fell somewhere sort of on this part of the diagram, right? Not completely in the control-based quadrant, but definitely in the vicinity and with less of the other things in its organization. And you know, we had a lot of traditional ops sysadmins. They helped build the company, and I really thank them for the work that they did. And at the time, it's exactly what we needed. When Facebook started in 2004, automation from an operations perspective was really young. Nobody really knew how to do it. Nobody really thought about automating your way out of a job. A lot of people really felt that if they became the single point of failure, that actually gave them job confidence, right? So it was understandable, absolutely. That's how we built the organization, but we needed to do something differently. Don't get me wrong, we did do operations did do some automation back then, but it just wasn't enough. Generally, actually, what they did was they depended on somebody else to build some tool for them, and they'd build some shell wrapper around it to actually get their work done. So we needed to move more from that corner a little bit more into this part of the diagram. And it's not dead center, and hopefully you'll understand why a little bit later. But we needed to move away from sort of the control model and add better tools to give us that control and insight into what was going on. We needed to make sure that we grew people internally and that we gave them better skill sets and take a chance on less experienced people. We needed to collaborate much better with other teams. And we still needed a level of control. Thank you. But not one mired in process or one that slowed the company down. So the other interesting thing that Jez said in his keynote was that hiring in for culture is difficult or that you can't hire. And I agree that actually that's pretty much a true statement. It's a really, really hard thing to do. But we did it. It was hard. It was, I think, I'm a little bit biased, but I think it was incredibly rewarding for us and the teams and the company in general because we're in a better state now. But there were some growing pains along the way. So the first thing that we needed to do was we needed to figure out what kind of culture we had and what kind of culture we wanted. And as we figure out what we wanted, it wasn't sort of an overnight thing. It was actually like a period of months and months to figure out what that culture looked like. We would talk to people over and over again, sometimes to our sort of jaded tenure operations people who were already angry because they were on call all the time and couldn't see the end of the light, but basically because we needed them to evolve and think differently about operations. And also the engineering teams, because they didn't really grasp the concept of what we were trying to build and what it meant to actually build automation and tooling in an operations organization. So we narrowed down the type of person that we wanted, and we just focused on hiring those types of people. In our case, we still wanted strong technical leadership, strong subject matter expertise, sort of still a little bit unicornish, is what I was talking before. But we also wanted team builders. We wanted people who did and thought differently about operations and automation. People who thought about automation as the first step to solving a problem, not the last step to doing it. We didn't want traditional sysadmins who in their own right were probably very strong. But traditionally for them, automation meant write a CF engine policy or build a shell wrapper and like deploy it, right? This just wasn't enough. We needed to really own our own destiny from an operations perspective, and we needed to write our own tools. Not someone else's idea of what we wanted for that tool. I firmly believe that if you're the one that's living the pain day to day, you're probably going to write something better than if you hand a spec over to somebody else and have them try to actually understand what you're going through. We also wanted to invest in new grads and in less experienced people, so we had to change the way that we actually thought about our candidates. Lastly, we wanted to keep the bar high, so we actually brought in software engineers from the software engineering organization to do a secondary coding interview to all the candidates that we had that could do an algorithmic coding one rather than a practical one. We had enough people who actually had classical CS trained backgrounds, But we were asking a lot of practical questions because we needed to know that you could do the work that you needed to do when you got in. But we also wanted to know whether you had sort of algorithmic skills to think about big design and software. And as we brought more and more people on, we realized that a fast-paced environment like Facebook, we needed to do a better job of onboarding people, particularly if we were going to take small gambles on skill sets or experience. We used to call it when you came at Facebook that like all the information that was thrown at you was like opening a fire hose in your face. And it wasn't going to scale either. So in the beginning, we agreed that it was okay for someone to come into the organization and not be strong in all technical dimensions, all 4 of them. You had to be strong in 3, but you could be competent at a 4th. If we could see some potential and you could do okay, then we would actually bring you in and grow you. So we built a mentorship program inside operations and told people that it was part of their job to actually grow people. We were going to evaluate them at how well they did that. Were they able to pass on their skills to somebody else? Could they get out of the single point of failure mode that they were in? And that became part of their sort of evaluation process, and that actually dictated their bonus as well. So if you were a noob coming in and you weren't as strong, say, on networking as you were on coding, we paired you up with a strong networking person that we already had in the organization. Or we tried to slot you into a team that was heavily network-based so that you had to learn that and become much more awesome than you were coming into the organization. I think that if you develop people, you can keep them engaged in new things. They gain much more out of the experience than just coming to a job because they learn that there are actually other things that they don't know about that will make them stronger. The other thing that we do is we also move people around about every 18 to 24 months from the teams that they're in, because we don't want them to get stuck in a rut. You can be a strong storage engineer, for example, but if you don't know anything about memory-based systems or caches, we'll actually sort of suggest that you actually move into that team about 18 to 24 months into your career at Facebook, so that at the end of your career, a couple of years after that maybe, 4 to 6 hopefully, or more, you just become stronger. You actually can take a lot more skills with you. Yeah. And as we hired more people, we were actually able to build new teams. At this point now in our history, we actually cover all of the big infrastructure services at Facebook, and we're investing in some new ones that we haven't invested in yet. But venturing into these new services and building new teams came with its own set of challenges. Along the way, we encountered, like I said, people in engineering who, and people in our own teams who didn't buy into the concept of bringing in an engineer to do operations, not a sysadmin. People thought that if we brought more operations people into the mix, it was going to slow them down. We had incoming software engineers who had preconceived ideas because in operations, in companies that they were at previously, they definitely slowed things down. They had seen ops clamp down. They had seen them get procedural, build change management boards. Basically all these things to make sure that operations knew what was going to happen in production, right? And we were actually trying to do the opposite. We were hiring tool builders and engineers to actually build systems that allowed the engineers to work faster in their infrastructure, but do it all in a controlled and repeatable manner, right? It was completely new to a bunch of different people. For the folks on our own teams who didn't evolve or didn't agree with the way of doing work, or they just didn't want to do it, we definitely tried to find them spots in the organization elsewhere. Some people decided to leave. It wasn't for them. That's okay. We can build things that are not good enough for other people. Or we cordially invited them to leave as well. So these were tough conversations, right? Like when you're changing a culture and when changing a mindset, it's a lot of difficulty with like, why are you doing this? Why are you doing that? You have to like stay on point and stay on message. But I think they needed to happen if we wanted to succeed in building a different organization than the one that we had before. Lastly, sort of to change minds and perceptions, I think John, I believe, from Twitter, or Jonathan, sorry, he was talking about that your leadership has to actually believe in that messaging. And in our case, a lot of us did. Our VP of infrastructure happens to be like our biggest cheerleader of the changes that we've made in operations. So it helped sort of sell that message. Yeah, the org continued to evolve. Yes, it was a little bit different than what people were used to. And I've told many an ops engineer that actually joins the company that their job isn't to say no, as if they would have probably done at previous companies, but it's actually to say yes, with a caveat. When you're working with the engineering teams, it has to be sort of a collaborative approach. It has to be a team effort between the two teams. Ops isn't there to just turn the crank and fix your dead servers or do the work that you don't want to do. The engineering teams have to commit to actually using common infrastructure so that we have a more sane way of managing the systems at scale. Generally, we actually also have the software engineers on call for their rotations. It's not just operations. My expectation and our expectation in general is that if you're a software engineer and you built a system, you own it in production. It's not operations that owns it. Operations is going to be there if the shit hits the fan, and they'll help you fix it, and they'll work with you in that firefight to actually make sure that we can bring it up. They'll give you all ideas about instrumentation and tell you what's going on because they're fast at the keyboard and that kind of stuff. But they're not the ones that are going to fix it for you, and then you can go off to sleep, right? From an operations perspective, every engineer really needs to learn what it means to run a system in production. So now it wasn't enough that we had software engineers helping interview. It wasn't enough that they were getting a better idea of the skill set that we were actually hiring. It wasn't enough that we were embedded and had larger teams working on scalability, reliability, and performance. We actually needed the software engineers to think more like operations and understand what it means to run a system in production. So now we were armed with people that could speak both languages. They knew operations and systems, and they knew software engineering and design. And we started infusing them with the operations mindset. And that's actually been pretty successful. We have a lot of teams now in engineering who, when they're building a new system, they actually ask the right questions around scalability, reliability, operability in production. And they do that before they actually roll it out to the fleet or even out to production. We collaborate on solutions. Sometimes there are heated discussions. We have a lot of people who are smart, so you get a lot of heated discussions around what's good and what's bad. But generally, everybody's sort of there for the same goal and like building an infrastructure that's reliable to serve our users. My sense is that if software engineers think much more like operations, then things are going to be easier. And I said one of the ways that we really ingrained it into them is by having them on the on-call rotation. It forces them to really understand the day-to-day pain of what it means to actually run that system in production. And the other thing is that when they're off their on-call rotation, they actually try to fix those problems because nobody wants to deal with that same problem when your on-call rotation comes the next time, right? So the main takeaway from what I've been talking about here is that it really sort of takes people to make things happen, right? You can never really underestimate the strength of a working relationship or socialization between other people or making them think about different things. Without the right people, it doesn't really work the same. Everyone involved needs to be open to new ideas and challenge their perceptions and perspectives. They have to really think that they're actually going to be one team rather than two different teams. And you can invest a lot of time in tools and processes for automation, but ultimately people build those. If the people building those don't actually have the right perspective, then you're not going to have a really good recipe for success. And now scaling an organization to accommodate a growing site like Facebook does still require tooling. It's not that we don't do actually any technical work. So I'm going to briefly talk a little bit about how we approach some of the tooling and automation things in operations. So I think earlier I said that we used to fix and repair and like reintroduce machines into production manually, or we'd run some command across the fleet in a distributed fashion to fix the problem. So SRO's mandate was to keep the site up and running and do it by whatever means necessary. And if that means humans on the keyboard, then that was fine. But that doesn't really scale well if you're having a human types things for every outage. It burns people out. It becomes a really horrible place to work. You're really burned out by the end of your day. You never get to work on interesting things. So we had to do something about that. So SRO embarked on sort of building tools that were focused on fleet-wide management. And we iterated quite a bit on that, and I'll get to some of that at the end. It was initially for me, it was interesting and surprising that no team had actually built something that was going to try and manage systems fleet-wide. But then I took a step back and I thought it actually makes sense. If you have a human that's turning the crank for you and they're fixing the problems for you all the time and they're doing it day in and day out and they generally don't want to fix it themselves or they don't know how, then what's your incentive to change? That human can do that work for me. Why should I actually do something different? And solving fleet-wide problems, yes, it's a difficult task. You have to know a lot about all the individual components of the site and how they come together and how they work together. And SRO was sort of the central point of all those services, and they knew a lot about each of the individual ones. So it kind of makes sense to me for SRO to own the fleet-wide server management problem. So off to the side, we had a small software engineering team that was focused on building better monitoring that could scale with our environment. And they built an agent that actually lives on each server. It runs a local command, it gets a lot of information, and then sends it back to centralized sets of systems that gives us sort of statistics and metrics about each system. And it's kind of like a remote Nagio system with a lot more brainpower behind it. So the first thing we did was we just piggybacked on that. And we said, we'll write a set of scripts that run locally on every machine. It checked things like, is the web server up? If it's not, restart it, right? Does it have the right build of the environment? And if it doesn't, push that build, restart the web server and see if that works. Check if you're out of disk space. Unfortunately, even when we were out of disk space, sometimes we didn't know what to delete, so we had to escalate to a human. When in doubt, if nothing else works, reboot the server, see if it comes back up, right? Do things like that. When those things failed, it still actually let a human deal with it. And it was very rudimentary, but it took away a considerable amount of manual effort that we were doing on a day-to-day basis so that we could actually focus on the end goal. The logic was good, but it was primitive. It didn't really have a lot of understanding of the system's health from sort of a global perspective. It wasn't hooked in very well with the monitoring system to basically get an idea of what was going on. But it was okay that we sort of cobbled it together with, Twix and Stigs and sticks and twigs and chewing gum, because we knew it wasn't the final solution. We just needed to stop the pain and put a Band-Aid on it for a little while we worked on something that was better. So that got us to a point that we could do some of that stuff, and we started building a system called FBAR. It's called Facebook Automated Remediation. And since SRO still needed to pay attention to those alerts, and they came back to humans, instead of having a human do what a computer is probably better at, we actually just built a computer that could do what a human can do, right? It will understand things that are in the infrastructure when they're broken, and it basically can do things like recipes for if this happens, then do this. And it's just the same thing that a human would do on a system. You log on, you try to do a couple of PSs or something like that, see if the service is running. If it's not, restart it. Just do all those things in a very orderly fashion and understanding the dependency tree. But FBAR constantly runs in the background and fetches alert from the centralized queue of alerting. It calculates sort of the appropriate workflows and the dependencies, inserts those into a job queue, and then it executes that queue. And it can run these workflows across the infrastructure in parallel all the time. And each workflow is basically just a plugin. Each plugin is written against the FBAR API. Each API component then hooks into other APIs in the infrastructure. So for example, the hardware API is something that allows us to just check individual hardware components. Is the memory that we're supposed to have on that system actually the memory that we have or that it's represented? Do we have the right amount of hard drives and are they configured correctly? That kind of stuff. The repair API may then use the hardware API to just decide whether or not a machine should go and repair based on a lot of the exit criteria for those functions. And actually, the funny thing about that is that the hardware and repair API were written by our site ops data center folks. These are the people that traditionally at any other company do rack and stack and plug in network equipment, and that's all they do. These folks actually were taking a similar approach to ours, which was build the tools that you need to do to make your job better. So I'll walk you really quickly through one of the workflows, and I'm going to use sort of a fail hard drive as a use case. So the alert goes off because the web server is not responding or is down or something like that. The local agent runs a couple of scripts, comes back with a picture of the server's health, and then FBAR takes that information, digests it, runs a set of plugins on it in a specific order in the dependency tree, and then let's say the first remediation plugin finds that the machine has a damaged hard drive. So it knows that if you have a damaged hard drive, then probably nothing's going to work. So I'm going to take it out of production. I'm not going to check that if HTTP is running or if SSH is running, because none of those things will be running anyway if you have a damaged hard drive. So we removes that server from production, flags the machine for repair for a human to fix it. We still haven't fixed that problem. A human still has to fix hardware. But if the plugin fails for some reason, it'll escalate to a human. If not, it resolves it and removes that alert. We all move on. FBAR has libraries that basically are built to understand I'm a newsfeed server or I'm a cache server. You have to remove me from this internal system and that internal system so that I don't get new data coming to me, et cetera, et cetera. And the logic and the code on all those is all written mostly by SRO and production engineering. Now, instrumentation is still a big part of understanding what's happening in production. And my sense is that if you can't measure something, you don't know how to improve it, right? So in addition to building tools, SRO and PE are actually focused on a good amount on adding and understanding instrumentation and making sure that we have the right metrics. This was the first version of our sort of dashboard instrumentation that we actually looked at from an SRO perspective. And it gave us an overview of what was happening on the site. But this was the problem. It was just too much data, right? Like SRO was supposed to watch this dashboard and then try to understand what was going on, but it's just too much for a human to digest. You don't know when this line goes up or down. Is it a good thing or a bad thing? You just know that the line went down, right? You'd have to have tribal knowledge about whether that line actually meant, that line going down meant a good or a bad thing. So instead, we actually built something different. We took a lot of those data points and we moved to something that's just much more easily understood. We took that data from those trends in the graphs and we added a lot of logic in the background to understand what those thresholds meant and what those trends did. And we built sort of like a heads-up display system that's easily customizable for everybody. It's just widgets that you can move around to make it look whatever way you want to. There's a lot of engineering teams that now actually use this to understand sort of at a quick glance what the health of their service looks like. But because it actually tells you where the trouble spot is, your eye can move very, very quickly to here's the problem. In this case, I think it was cache systems. I can't remember. The screenshot was a long time ago. And you can click through, and that will take you to other systems so that you can actually do some more diagnostics and understanding the trends, right? Additionally, we also took a look at the pieces of infrastructure that depended on some third-party company. One of the biggest problems that we had was our load balancing infrastructure. The system that we used, the vendor that we used, and the company that built it really never envisioned us using hundreds or thousands of these types of devices on our network, configured in slightly different ways and managed by one or two people. They weren't built that way. That's not their bread and butter. So we realized that was hindering a lot of our productivity. We couldn't actually do a lot of the things we needed to on the infrastructure because our load balancing took too long. So we worked with the software engineering build to build an in-house load balancer named ProxyGen. You can look it up. There's a bunch of talks online about that. And production engineering had a huge part in actually building the system and also the outcome for it. At this time also, we ended up owning some pieces of infrastructure. So for example, production engineering built our global load balancer that we actually use today in production. We just reused open source components and made some modifications to it to work faster or to work at our scale. But it's way smarter than any off-the-shelf appliance that we actually can use because we own the code completely. We can iterate on it very, very fast, and we can push a new version out whenever we want to. We can take a variety of inputs into account and make smarter decisions around routing, for example. And today, it shuffles traffic around the infrastructure all day long, and no human ever has to pay attention to it unless something goes wrong. So one of the things that you're probably also thinking about right now is how do we deal with the inevitable need to actually control things in production and what's going out and what's happening in production. So operation definitely needs to know what's going on to be able to run the site smoothly. But because operations isn't generally the set of people who are actually pushing things out to production, we don't know everything. What we do is we partner really closely with the software engineering teams to make sure that every deployment methodology that we have on the site, we have a few, not too many, but just a few right now, that we built the right mechanisms to make sure that we can roll things back quickly, that we test in production very slowly. And this is the reason why I think that we can actually take a lot of risks in production. Our systems are built to put things out there very quickly and roll them back very quickly. We have a standard set of guidelines and tools that push in a measured way so that you can understand those metrics before you actually continue the rollout. We build safety mechanisms so that if you have a new person on the engineering team and they think, I'm going to just push this out to 100% of the servers all the time, it pauses you and says, are you sure you want to do that? Right? And so with all these different ways of changing things in production, we actually did need a centralized tool to understand all of those changes. So operations built this tool, aptly named OpsStream. And it's just a lightweight system that has a couple of endpoints that you can, and libraries that you can import to your deployment tools that will log information from command line scripts or pull information from other tools that we use today to actually change things in production. So for example, here you can see that at the beginning, somebody was rolling our new cache binary out. And there were a bunch of gatekeeper changes. And gatekeeper, I think we talked about it in the past, a couple of companies like Google and Twitter have these things where we can actually exercise the code base in production without actually affecting all our users. We can just slice and dice a couple of users and say, try this new piece of code base, and then we can understand whether or not it's actually failing in production, and then turn it off really, really quickly. So the nice thing about this tool is it tells us when the change happened, what the change was, and who did it. So that if there's a problem, we can quickly understand if the change that we made caused this outage. We can engage the engineer who actually did it. We know exactly who made that change, and we can talk to them and say, hey, we have an outage. Did your change actually cause this problem? Operations has the ability to roll back all of these things. We can go into all these systems, and if we can't get a hold of the person or we're not quite sure, we think it might be, we actually will roll it back anyway. So we feel that this is the right approach to understanding what changed in production and sort of the right level of control to continue to move fast. The last tool I'm going to touch on is a tool named Cobalt. So remember I told you at the beginning of the presentation that it used to take us 6 to 8 weeks to roll out a new cluster of about 10,000 servers. So cluster ops focused on Cobalt to make this process a lot faster. They built a Python-based system. It's dependency-based. It understands how to image servers from the imaging system. It understands how to add them to the right load balancers, what internal systems it has to add them to configure them and push to them, and then start bringing traffic online, how to warm up our memcache servers from the databases, et cetera. It understands what ratio of web servers we have to cache servers depending on the size of the cluster. So it has a lot of knowledge and brain power behind it. And now that process actually takes us 3 to 4 hours. And I think this is the third iteration that we've gone to, and I think at this point we can just pretty say that we're good on not improving over 3 or 4 hours. Now the thing that we have to do is we have to make sure it doesn't regress. So every time that we add a new service, we need to make sure that it's automated and instrumented in this way so that when we add a new service into production, we can actually bring it up in any front-end cluster. So now I'll come back a little bit to the graph I showed you before to revisit what we had talked about. So we embedded more people directly into engineering, and they became part of the team. We build tools that give us the insight into what's changed and the control to fix things really quickly. We hired people that can do what's necessary to succeed and infuse others with their expertise and their knowledge. And then we invested in their future and careers to make them a lot stronger. So it kind of brings us to where I said we should be. Enough control and speed that we're comfortable with the operation of the site, but not too much that it actually stifles innovation. That's all I had to say, folks. So I'm here if you guys have questions. Go ahead.
Can you talk about any strategies you have for pulling back information that you gain from the people that you're embedded in these teams?
Strategies to pull back information from the people who are embedded in these teams. We use Facebook a lot. We actually use the internal tool quite a bit. We talk to people about having discussions about architecture and then going back and posting it as an internal post. We use groups as a big way for us to disseminate information. We use groups internally to ask questions about if somebody's wrote this other tool and can it be used or applied somewhere else. The postmortem process is a big one, right? When we get together on a weekly basis, we do bring in usually a couple of people from the engineering team that own that system, and then we understand more. They'll give us like a really quick architectural overview. We have a core set of people who are in that meeting every week who kind of have all the knowledge of the infrastructure in their head, and so when they come and talk about things, we know that like this is connected to that other thing, and they can help us understand whether we have to do it differently. Does that help you? How do we measure the size of the team? So I actually had a slide about this, but I took it out. We actually try to keep our teams really, really small. The reason why we do that is because when you have a small team and you're constrained, you will only really work on the high impact stuff. You won't pick the stuff that's like boring, or you won't try to find work to keep your job. There's always a plethora of things available for you to do. Now, it does come with the fallout that you will drop some things. You will not get some things done. And picking the size of the team it's more of an art than it is a science. It's just discussing with the team how they're overloaded, how much they're doing, looking at the roadmaps over the course of the next 6 to 12 months, and then doing some prioritization around if we added this person, now that we've had this automation, how much work are they going to have to do versus do they have to build the automation? So generally, for example, in SRO, one of the things that we did was we doubled or more the size of the team almost immediately for the first year because we knew that we just needed the people to do the work. And then over time, we are actually tailing it back because we don't have as much work that's necessary to do that kind of stuff. And then we shuffle the people off to other teams, right? So it will ebb and flow on the size of the team all the time. I wish I could give you a strict answer, but it's kind of an art, really. I can talk to more later offline if you want. Yep.
That goes from application libraries down to system libraries, like web server, may need a version of some C++ library that depends on the operating system, libraries, etc. How well is that controlled and managed?
So we have a system very similar to what Twitter was talking about in terms of Mesos. We actually have a system that orchestrates and understands the packaging of a binary in a cheroot and sends it out to there. We stop generally our automation at that level. So from the operations perspective, we deal with, there's a blob or binary that has to go out to the system. All we need to know is where to pull it from. We today, in some places, we are actually adding local instrumentation to the system to say, if you're a CAS server and you're overloaded, you're not answering network, is it because you're out of CPU or not, right? Things like that. But we kind of draw the line at that point. And that dependency tree of what's required on the server itself is handled by the software engineers who understand it. And so they'll pull the libraries that they need to, put it into root, and then send it out. And then FBAR just understands, hey, I had this blob and binary, I have to find a replacement server just like this one, put it over here. If you're not on this new system that we have, if you are on this new system that we call Tupperware, you actually, the scheduler handles that for you. So, yep. Yeah.
Did you have people working in different time zones? And if so, did you have the same types of people, the same work in all locations?
Yeah, we do have people today in different time zones. We have people in Dublin and in Menlo Park, California. The skill set is an interesting one. Our peak for the site is actually at about 11 o'clock in the morning to about 3 o'clock in the afternoon, Pacific time. So overnight with Dublin, they take over now at 11 o'clock at night is when they take over to sort of like effectively watching the site. They have a lot more time because a lot of things don't break when we're at trough. We have a lot of excess capacity, so the problems are lessened. So what we learned is that because we have a lot more time in those time zones, we hired a higher caliber of person to be able to work on other different things. We're now starting to invest in having the overnight folks own pieces of infrastructure outright and have them do the same thing that we did here, which is you're now going to be on call at night if your system breaks, right? From an engineering perspective, this one's a little bit much more difficult right now. I think that there are teams that are spread apart. We have teams in London, we have teams in New York, in California. Generally, we don't have a project that spans all three because the time zone is actually very difficult to work around. You have people who come on, who in London are coming off their day and in Menlo Park are starting at their day, and you have like an overlap of an hour maybe, and that becomes really difficult to like solve big problems in that sense. We're still trying to figure it out. I'm sure we'll come up with something interesting, but today it is a challenge for us. Yeah. So. Cool. Thank you.